Hello friends, today we'll derive the motional induced EMF in a conducting rod rotated in a magnetic field. So this is a circular path. So we can see the it is rotated in a angular frequency omega. Okay, and this is a L is the radius here, alpha is the angle. So this is a kind of, you can take it as a corresponding to a height. That's why it is L alpha. Okay, so move to the derivation part. A is equal to what? Half base into height. So here is base is the radius L, and it is actually kind of a hypotenuse you are seeing, but it is not a hypotenuse, and it is not the height. It is actually corresponding to a height. You can also say it is corresponding to the hypotenuse, but it seems like, so we can assume it L alpha. Okay, L alpha is the height. So when we'll multiply it, so we'll get the proper area. Well, area. Now what is the flux? Flux is a BA. Okay, magnetic field into area, cross sectional area. So B into area, we'll write area, instead of area we'll write this. Okay, and now from the second law of Faraday's, we can say E equal to minus d phi by dt. Okay, flux, change in flux divided by time. So now what we'll do, we'll put phi value here for in the differentiation form. Now it's minus b L square by 2 d alpha by dt. What is d alpha by dt? D alpha by dt is omega. So put here omega, and now we'll take the mode. Okay, well, if you take the mode, so it will become this. So it is the finally derivation. Thank you. We'll look at the proper derivation. Hello friends, today we will derive the motional electromotive force. So here we go for flux, magnetic flux, which is equal to VA. Okay, it is a magnetic field and it's a cross-sectional area. Okay, so from we can see in the figure, if we find the area, then what is the area? The length is L and the width is X. So the area will be, what is the area here? Area is XL. Okay, XL is the area. So we'll put area here LX. Okay, now what we'll do, we'll differentiate with respect to time. Okay, differentiate with respect to time. Okay, so here this will become the velocity, because the instantaneous velocity is dx by dt. So we can write VLV. Now what we'll do, we know that the flux, the EMF is equal to minus del phi by del t. Okay, dt. So it is the EMF induced is equal to this. So now what we'll do, we'll put the value here. Okay, this will be minus BLV. So when we'll so E is equal to this minus BLV, magnetic field length into velocity. Okay, but now if we will take a mod, like mod, it will become a positive BLV. Okay, now if we find the current, like current is equal to E by R. Okay, why? E is just, it is a V, it is a potential difference, kind of potential difference, but it is the EMF. EMF will be measured in ohm, and potential is also measured in ohm. So both is equal. If you see in my point of view. Okay, so put instead of E, okay, put VLV by R. So I is equal to VLB by R. Okay, I equal to VLB by R. So that's it. Okay, thank you. Hello friends, today we'll derive the power in EMI. Okay, so what is the power of EMI? So before we're gonna find it power, we should know the force. Force is what? Force is I L L cross B. Okay, so this is a force, and if we eliminating the cross section, if we eliminating the cross, so what we'll do, we'll take the sine theta, but take the sine theta in the 90-degree, so it will become a 1. So ILB. Okay, it's the force. Okay, now what you will do, you will you will take this equation 1, and you should know the current is actually what, E by R, and what is it is a VBL by R. Okay, in the motional form we know EMF is equal to E by L, EBL. Okay, so you know the I value, put the I value here, so it will become LVL by R into LB. Okay, now it becomes B square VL square by R. Okay, now power. So it is the force. Okay, you derive the force. So it is the force. What you derive? Force is equal to B square L. Okay, this is the force. Now what we'll do? We'll derive the power. Power is equal to PV. Okay, FP. So this is a power, and power equal to F. F is what? B square V L square by R into V. So B square V square L square by R. So power is equal to VB whole square by R. So this is a power. And alternately, if you want to prove power, so power is equal to what? I square by R. Put the I value. Like we found the I value, so put the R value. It will become B square L square L. Okay, by R square into R. Okay, it will become this. Okay, so this is the alternative form of power. You can also say this is a form of power. Okay, but in general you should go for this. Okay, look at the proper form. Okay, thank you. Hello friends, today we'll derive the energy stored in an inductor. Okay, so what we'll do, so we should know the this. Okay, V equal to W by Q. Okay, from 10th class, the potential difference formula. But instead of potential difference, we'll take what? We'll take E. Okay, we'll take EMF is equal to W by Q. But here we'll take W, like we'll take the work done in elementary form, and also the charge in the elementary form. So here D work done in an elementary form is equal to E dq. Okay, so this is it, and we should know the what is EMF is d del phi by d del t. It is the EMF. So and if we know the induction, like Li, phi is also equal to Li. Okay, Li. So put L in this, so we'll get dy dt Li. Okay, L will be the constant, so L will out, so it will become d L dy dt. Okay, so this is it. So you're having this equation, put this equation here. Okay, like here, L di by dt equal to dq. Now L and dq by dt is what? So dq by dt is equal to I. So that's why I wrote I is equal to di. So now integrate to the both side. Okay, now what we'll do, we'll integrate the both side, and it will become, we'll take it from 0 to u and here 0 to I. Now it is become a definite form of integral. Okay, so u equal to L I di. Now I, what is the integration form of IDL? I square by 2. Okay, by 2. So this is done. Okay, so u equal to half L I square. This is the energy, u is the energy, L is the inductance, and I naught square is the current. Okay, so this is proved. Look at the proper equation. Okay, this is it. Thank you. Hello friends, today we'll derive the self-inductance in a solenoid. Okay, so this is a solenoid, it is a coil. Okay, and there is current passing through it and going through it. Okay, let's go. So for derivation we should know this magnetic field is equal to this. Okay, and n is the number of turns. Number of turns is equal to this total number of turn. This is the length. Okay, this is the length of the solenoid. L is the length of the solenoid. So total, it is a total number of turns. Okay, total number of turns. Now what we'll do, we know the flux, magnetic flux formula. Magnetic flux formula is BA. But if you're finding in the terms of turn, so you'll multiply the turn. Okay, now you should put this value, magnetic field value, and now area. What is area? Area you should write it as A, and n is NL. Okay, so when you solve this, it become n square AIL. Okay, n square AIL. Okay, this is like this, and you should know this, the phi is equal to Li. Okay, phi is Li, L is the inductance, I is the current. Okay, so put here IL equal to this. Okay, now cancel the I here, and we left with L equal to this. Okay, so if you are finding in terms of n equal to L by L, put this value here, so we'll get L equal to n square L square AL, 1 L cancel. So this is another form. Okay, this is what we had to prove, and we proved it. And thank you. Hello friends, here we'll go to understand the what is the AC generator and how it's work. So it is a magnet north and south, and you see this dotted line is the axis of rotation, and this is the amateur, and well taking it as an angle theta of its rotation. So theta is equal to Wt, which is the angular frequency into the time. Okay, so we can apply the EMF formula here, which is d flux by dt. Okay, so this is what, and you should know the what is phi here. Phi is equal to Ba. Okay, Ba, and it is a dot product. Okay, so it is a dot product, so here is a cos theta. Okay, cos theta. Okay, but here theta is what? Omega t. So we'll write, instead of theta we'll write omega t. Okay, this is our flask. Now put this flask here in that. So d by d theta is equal to Ba cos omega t. Now what you need to do, you need to take out B and A from here as a constant. So d by d theta is cos omega t. We know the differentiation of cos theta. So what is the differentiation of cos x? So it is the minus sin x. Okay, minus sin x. Okay, sin differentiation is cos x. So here is also the minus. Okay, so that is a form of Faraday's second laws. So now what we'll do, so here we write minus Ba equal to, so omega will be out because it is the constant. Omega will out and it will become minus sine omega t. Okay, so now it becomes minus minus will become plus. So Ba omega is equal to sine omega t. Okay, but here, like if it has a number of turns also. Okay, it is rotating to it will has the number of turn. So that's why it is the general formula of EMF will become minus n df by dt. Okay, so here will be the n, and here will be the n, and here will be the n, here will be the n. So here will be the n. Okay, so this will be the n. Okay, so compare this formula with this, like E is equal to E naught sine omega t, and when you comparing with E equal to n Ba omega sine omega t, so E naught is equal to this whole. So E naught is equal to n Ba omega. So that's it. Thank you. Hello friends, today we'll find the relation between a charge flowing in a circuit and a change in flux. So we'll find the relation between this phi and this is the charge Q. Okay, so let's go. Okay, but here in change in flux will be del phi, and change in charge will be the del Q. Okay, so we'll find the relation between this. So we should know what is the EMF. EMF is equal to del phi by del t. Okay, del phi by del t. Actually this is what, like if you taking it as this, like del t by del t, if you're taking a limit which is x, del t x tend to 0, it will become E t by dt. Okay, this is nothing, just a kind of a differential formula. So let's go. Okay, so this is what, so there will be no confusion, that's why I wrote it. And this, take this as equation 1, and you should know the EMF is equal to IR. Okay, IR. So what is IR? Is actually, it is from the Ohm's law. Okay, now what you need to do, you should know the value of I. I is equal to del Q by del T. This is the similar form. Okay, this is, I am writing in the change in charge flowing through the change in time, change in flux divided by change in time. So so it is the del. Okay, so if you have no doubt, I will try to explain you through this. So if I is equal to del Q by del T, okay, and if you taking the limit of del T extends to 0, then I is equal to dq by dt. Okay, so this is gonna be, so here is nothing, instead of I will write del charge by del T equal to R. Okay, this will be the equation 2. Now what you will do, equate equation 1 and equation 2. Okay, when you equate the equation 1 and 2, you will get del plus del T equal to del Q by del T into R. Okay, so here you can cancel the del T, and finally we left with del Q is equal to del phi by R. Okay, so this is it. Okay, this is what we derived. This is the relationship. Okay, this is the relationship between charge flowing and change in flux. Okay, thank you. So look at the proper. Thank you. Hello friends, today we'll derive the equation which is equivalent self-inductance of a group of a cell, of a coil. Okay, cells, if cell is connected in series, and if cell is connected in parallel. Okay, so we'll derive these two both in a same video. So let's go. Okay, so we know that the EMF is equal to this minus del by phi by dt, change in flux, difference in the change in flux in the change in time. Okay, so this is a flux, this is a induced EMF formula. Okay, we know that the phi is equal to Li. Okay, L is the inductance and I is the current. So if we put here in the phi this, and will be differentiated, so it will become minus L d by it. Okay, it will become this. Now what we'll do, from here we're seeing the diagram. So this is the inductance L1 and this is the inductance L2. So what we'll do, we'll take the EMF which is equal to the I1, E1 and E2. Okay, this is the EMF. Okay, so for E we have this. So for E1 we will have minus Li1 di by dt, because the current is same. Okay, the current is I here, so current is the constant in each of them, and this, and secondly E2 is equal to minus L di by dt. So this is the second. Put E1 and E2 values here and E values here. So L is become to this minus di by dt plus, not, it is minus L di by dt. Okay, so now take the minus as a common. Okay, here is the I1 and here is the I2. Okay, so take the minus and di by dt is the common, so it will become L1 plus L2. Okay, it will become the L1 and L2. Now what you need to do, cancel the minus sign, cancel the di by dt in the both, okay, and you left L from here and L1 plus L2. So it is proved. It is proved. Okay. Now we will go to derive the cells. If the cells connected in parallel, okay. If the cells connected in parallel, so we can say if we pass the current I from A to B, so it will divide. The current will divide in I1 and I2. Okay, the current will divide in respectively L1 and L2. Okay, so if these are in parallel, so current is going to I plus I equal to I1 plus I2. Okay, so this is a current which is equal to I1 plus I2. Now what we'll do, we should know the I value. So E is equal to what? Minus L di by dt. Okay, so from here we can say di by dt is equal to E by minus L. So this is equal to our first equation, and for E1 and E2 you to take the separately. Okay, so and the current is I. If we are taking the di1 divided by d2, dt is equal to minus E by L1. Take it as the equation 2. And if we are taking similarly we are taking it, okay, and di2 by dt is equal to minus E by L2. This will be our third equation. Put one equation in here and here, so we can't put it here. Okay, we should differentiate with respect to the time. So while we are differentiating with respect to the time, it will become, okay, now put the value here. Okay, in di by dt is equal to this, and di first is equal to dt is equal to this and this. So put 1 2 3 in the respective form. So we'll get minus Li equal to minus EL I minus EL2. Now what you will do, you will take the minus E common, so it will left Li plus this is gonna left. Now cancel the E and the minus sign, we're left with this. Okay, and this is it. Thank you for watching it. It is proved when the cell is connected in parallel. Okay, this has happened.